Is to show you how to use the calculator for a goodness of fit test. I'll use the M&M example from the chi-square intro notes. The first thing we want to do is we need to get the data into our calculators. So stat, edit, I'm going to put the observes in list 1 and the expecteds in list 2. Which I've already done. So if you need to, pause and get the data into your calculator. Once it's in there, we'll quit out of this and go stat tests, and this is where we keep all of our inference procedures. We don't use the z-test, but we have t-test, to-sample, t-test. So skip anything that's z in sample. We do use one prop z and two prop z. We'll skip z interval, we use t interval, now to sample t interval, and then our prop procedures. Don't get deked into the chi-square test. We'll save that for when we have our two-way tables. But for the goodness of fit test, if you're using a TI-84 or later, presumably you're going to have this test. If you're using the older TI-83s, there is not a goodness of fit test. And if you're one of those people, I'll show you kind of a workaround for that. But most of you are going to have this goodness of fit test, which we will select. And we put our observed values in list 1, our expected values in list 2, and we've got 1, 2, 3, 4, 5, 6 colors. So 5 degrees of freedom, and we hit calculate, and we have our chi-square statistic. So this is the sum of each of those observed values minus the expected squareds divided by the expected. All added up. And then the corresponding p-value that your calculator gives you there. If you use the table, the best you could do with the p-value is that it's between 5 and 10%, which is fine, but the calculator gives you the exact. What you notice there at the bottom, the CNTRB, are the contributions. So without hitting anything else, if you go to the right and go to the left, you can see these values. This first value, 2.025, what that is the first component of the sum. This number, 2.025, is 9 minus 14.4 squared over 14.4. If you cruise over to the next one, 1.33, that is 8 minus 12 squared over 12. So you have the contributions for each of the components of the sum. So I call them components or contributions. The reason these might be important is if you want to see which category was the biggest contributor to this 10.18, let's call it, which is the sum of all these contributions. And as you may have guessed, the biggest contributor looks like it's going to be the fourth one, the yellow, because we were off by 6.5 when we expected to get 8.4, which is a pretty big difference relative to what we expected. So this contribution of 5 is half of what's going on in the statistic that got us to 10. Just one of these was half of that value, which is surely the biggest contributor. We can check out the last couple there, but they're less than 1. So the biggest contributor, if we reject in the chi-square, we can go back and say, okay, the reason that I ended up rejecting is because this value, which corresponds to the yellow, was the biggest contributor. And at the 10% level, you would reject. So had you set your alpha to 10%, you would have rejected, and the biggest contributor to that would have been yellow. At the 5% level, though, which is the example we ran in the previous set of notes, we failed to reject. So while this was the biggest contributor, since we didn't end up rejecting, there's really no action item there. But noting that this is the biggest contributor is the follow-up analysis that I mentioned in the previous notes. And if you're good with that, that should be the end of the calculator used for the goodness of fit test. If you don't have the goodness of fit test, the kind of workaround to this would be stat edit, and then in your list 3, really the best we could do is the observes minus the expecteds squared divided by the expected. And when you run that, you get all of the contributions, just like we did on the goodness of fit test. They're all listed here. And you can add them up yourself or run a quick stat, one var stat of the data that's in L3 and sum it pretty quickly. You can see that the sum of the x's is this 10.18 number that we got earlier. So just a few extra clicks for those of you not able to use the goodness of fit test to get that value. The last thing, I guess, would be if you're not psyched about the goodness of fit test contributions, how they come up in that string on this page. Kind of like residuals, your calculator will save the contributions just like it saved the residuals when we ran regressions. So we just need to go call them up, and those are going to come from second stat, this list page. And you can see contributions there. Happens to be number 7 for me, might be somewhere else for you. I don't know the last time I ran a regression, but my residuals are in number 9 there. But if you choose contribution, you can throw those in a list and see your most recent goodness of fit contributions thrown in there. Just an easier way to see, okay, clearly the 4th one was the biggest contributor, which was yellow. So hopefully this gives you a little bit of guidance with the calculator as it relates to the chi-square goodness of fit test.